Good evening, students. In the last lecture, we have calculated the electric potential due to a dipole. We have studied two cases. The first one was axial one. In the axis of the dipole, we have calculated the potential. What is the axis? In this particular dipole, this can be the axis, this can be the axis. जो कि उसी लाइन में चल रहा हो वो उसकी एक्सिस होगी. And then we calculated the electric potential at the equatorial point. And equatorial point will be on 90 degree to that of the dipole. Now students, which case we are going to study? We are going to study at general point we have to calculate the dipole moment or the electric potential due to the dipole at any general point. That is a random point. कहीं पर भी हो सकता है point. तो ये point P मैंने consider किया है. Dipole आप देख सकते हैं. Here is a minus q charge. Here is a plus q charge. Okay, separated by a distance 2l. So center से जो distance होगी point B की, that will be l, and point A also having distance l from the center. तो point P जो मैंने general point लिया है, अब इस point को देखिए मैंने कुछ positions लिए हैं जो आपको समझने होंगे. So I have considered that this point P is at distance r2 from charge plus q, and the same point P is at a distance r1 from charge minus q. Okay, and this same point P is at a distance r from the center. तो r जो आप देख रहे हैं ये point P की center से distance. Okay, now students, I have considered the angle theta. अब ये theta angle किन दो फिजिकल क्वांटिटीज के बीच में है तो इसको समझते हैं. दिस इज चार्ज माइनस क्यू, दिस इज चार्ज प्लस क्यू. सो स्टूडेंट्स, जो डायपोल मोमेंट होगा उसकी जो डायरेक्शन होगी वो हमेशा माइनस क्यू से प्लस क्यू की ओर होती है. व्हाट इज डायपोल मोमेंट? दैट इज p is equal to q into 2l, either charge into distance between the charges. But the direction of dipole moment is always from minus q to plus q. So this is going to be the direction of dipole moment, this one on the right side, and this is the angle theta. So हम ये कह सकते हैं कि dipole moment की direction और line OP के बीच का angle है theta. So this we have considered for the position. Now अगर हम इसी OP line को पीछे आगे बढ़ाते हैं, okay, we will extend line OP till point C on the backward direction, and then we will draw a perpendicular. Okay, this is angle 90 degree. We have drawn a perpendicular which is meeting this at point A. Okay, minus q charge को point A पर मिलता है. In the similar way, from point B we have drawn a perpendicular on line OB. Okay, I hope you understood all these perpendiculars. अब इनकी length कितनी होगी वो हम calculate करेंगे. So I hope you understood all this diagram. So this is the next which I have written. You also have to write it. Now let us solve this. कुछ थोड़ा सा मैंने इसका कैलकुलेशन ऑलरेडी आपके लिए सॉल्व कर दिया है. So in triangle AOC, इस ट्रायंगल में देखिए, this angle is 90 degree. Okay, this is L. Now what is the value of cos theta? Cos theta is base upon hypotenuse. Okay, so this is base OC divided by what is the hypotenuse? L. So cos theta is equal to OC upon L. तो OC की वैल्यू कितनी आ जाएगी यहाँ से क्रॉस मल्टीप्लाई करके L cos theta. Now in the similar way apply the trigonometric ratios in this triangle OBD or BOD we can say. So what is the value of cos theta here? Cos theta is equal to base upon hypotenuse. So what is the base? OD. And what is the hypotenuse? Hypotenuse is opposite to 90. So hypotenuse is L. So cos theta is equal to OD upon L. OD की वैल्यू आ गई L cos theta. Why we have calculated this value? You will come to know when I will solve it further. तो अब स्टार्ट करते हैं. पोटेंशियल हम कैलकुलेट करने वाले थे पॉइंट P पर. ओके, ड्यू टू दिस डायपोल. दिस इज अ रैंडम पॉइंट, कहीं पर भी हम कंसीडर कर सकते हैं. नाउ लेट अस कैलकुलेट इलेक्ट्रिक पोटेंशियल ड्यू टू चार्ज minus q. Firstly, we have to calculate the electric potential due to charge minus q. I am denoting it as V1. So V1 is equal to, what is the electric potential due to a point charge? Already we have derived it. So 1 upon 4 pi epsilon naught q upon r, where r is the distance. So V1 is equal to 1 upon 4 pi epsilon naught minus Q divided by, what is R for this minus Q? R is at distance R1 from point P. So V1 is equal to 1 upon 4 pi epsilon naught minus Q upon R1. Now in the similar way, calculate electric potential due to charge plus Q. What will be the electric potential due to charge plus Q? V2 is equal to 1 upon 4 pi epsilon naught plus Q divided by distance is R2 plus Q upon R2. What will be the net potential? So net potential at point P, net potential के लिए क्या करना होगा? We have to add these two values. V is equal to V1 plus V2, and when you will add these two values, I am doing it directly. Q upon 4 pi epsilon naught, we can consider it common, and when we will consider this common, inside there will be 1 upon R2 minus 1 upon R. This value we will get जब हम इन दोनों को ऐड करेंगे. Now students, R2 और R1 की फॉर्म में सॉल्व करना थोड़ा सा डिफिकल्ट है, so that is why we will generalize the values. अब देखिए R1, अगर हम R1 डिस्टेंस की बात करें, R1 is actually AP. R1 distance in the form of vertex is AP, and AP is approximately equal to, I am not saying that is equal to, but approximately equal to CP. So AP और CP की values almost similar होगी, that is why we will take this sign, कुछ इस तरीके से हम दिखाएंगे approximately equal to CP, and this will be approximately equal to CP. So what will be the value of CP? Let us calculate this. CP will be OC plus OP. OC plus OP. Now students, what is the value of OC? देखिए OC हमने already calculate किया हुआ है. OC was L cos theta, and OP is equal to R. सेंटर से डिस्टेंस R थी और OC हमने कैलकुलेट किया था, that was L cos theta. So we are getting R plus L cos theta. That is the value of R1. Similarly, calculate the value of R2. अब देखिए R2 कितना होगा? R2 is dP and approximately equal to, not exactly equal to, dP is almost equal to dP. तो हम इतने डिस्टेंस dP को BP के ऑलमोस्ट इक्वल लेते हुए, अप्रॉक्सीमेटली इक्वल लेते हुए अभी कैलकुलेट करेंगे. सो R2 इज एक्चुअली इक्वल टू dP, ओके, सॉरी, R2 इज इक्वल टू BP एंड अप्रॉक्सीमेटली इक्वल टू dP. नाउ व्हाट विल बी द वैल्यू ऑफ dP? तो देखिए जो dP होगा दैट विल बी इक्वल टू OP माइनस OD. Now substitute the values. देखिए OP कितना होगा? OP already we know R, and what is the value of OD? देखिए OD हमने already calculate किया था, and that was equal to L cos theta. So R minus L cos theta. This is the value of R2. Now let us substitute these values in potential जो हमने calculate किया था. So net potential at point P. V is equal to V1 plus V2. So Q upon 4 pi epsilon naught already there is out from the bracket. 1 upon R2. So 1 upon R minus L cos theta minus 1 upon R1. So 1 upon R plus L cos theta. So V is equal to Q upon 4 pi epsilon naught R A minus B, A plus B, A square minus B square. Apply the identity. So R square minus L square cos square theta. So students, अब देखिए जब हम separate करेंगे, so what we will get by LCM? R plus L cos theta minus, तो साइन चेंज हो जाएगा, minus R plus L cos theta. So R and R gets cancel out. V is equal to Q upon 4 pi epsilon naught. L cos theta, 2L cos theta divided by R square minus L square cos square theta. Now Q into 2L. What is the value of Q into 2L? Q into 2L is dipole moment denoted by P. So we will write it as V is equal to Q upon 4 pi epsilon naught. Q into 2L will be P cos theta divided by R square minus L square cos square theta. I hope you are understanding this. Now we can consider R much, I don't have the space actually, so I am writing it here. We can consider R much greater than as compared to L, and when this will happen, V is equal to Q upon 4 pi epsilon naught. We can neglect out this term. R is much greater than L. P cos theta divided by this R square only. So this is the net potential at our general point due to a dipole. So this is the net potential at a general point. अब देखिए जो हमने डेरिवेशन किया ये फुली करेक्ट है या नहीं, तो इसको समझने के लिए हम दो स्पेशल केसेस कर सकते हैं. सो आई विल गिव यू द टाइम, यू कैन नोट इट डाउन. आई एम स्टैंडिंग हियर. अगर आपको स्क्रीनशॉट लेना हो तो आप ले सकते हैं इसका. ओके, सो आई होप यू हैव सीन इट वेल. स्क्रीनशॉट ले लीजिए क्योंकि कुछ मुझे इरेज करना पड़ेगा. ओके स्टूडेंट्स, नाउ the calculation which we have done is correct or not. For understanding this calculation, we have two special cases. So we are going to discuss all these special cases. Try to understand these cases. So very first case which we are assuming is special case. First, if point P is on axial line. स्टूडेंट्स, हमने अभी इसको जनरल पॉइंट पे कंसीडर किया था पॉइंट P को. अब हम इसको चेकआउट करते हैं कि क्या हमने सही किया है नहीं. तो पॉइंट P जनरल लाइन पर भी हो सकता है, एक्सियल लाइन पर इस डायपोल की जनरल एक्सियल लाइन पर भी हो सकता है. इफ दैट विल बी ऑन एनी जनरल पॉइंट, देन थीटा इज गोइंग टू बी हाउ मच? 0, because this is on the general line, on this line, so theta will be equal to 0. And when we will consider theta is equal to 0, so V is equal to Q upon 4 pi epsilon naught P cos 0 upon R square. इस फॉर्मूले में थीटा को 0 रख देंगे. ओके, सो व्हाट इज cos 0? दैट इज 1. सो V you are getting inversely proportional to R square by using this. और एक्सियल लाइन में जो हमने पहले डेरिवेशन किया है वहाँ पर भी इलेक्ट्रिक पोटेंशियल जो था ऑन एक्सियल लाइन वाज इनवर्सली प्रोपोर्शनल टू R square, so that we can say we have done it in correct. Okay, now if point P is on equatorial line, देखिए अगर पॉइंट P इक्वेटोरियल लाइन में होगा तो कितना एंगल बनाएगा? That point P is on equatorial line, so this angle will be with the center, theta will be 90 degree. अगर थीटा 90 डिग्री होगा, ओके, सब्स्टिट्यूट द वैल्यू ऑफ थीटा. V is equal to Q upon 4 pi epsilon naught P cos theta. P cos 90 divided by R square. Cos 90 is how much? 0. So what is the electric potential? 0 on equatorial line. So we have checked our general formula for axial line and for equatorial line, and we found it correct for both the cases. So that is why we can say we have done it in correct manner, and I hope you understood this derivation. Thank you. God bless you.